This is the second video for lesson 7-3, all about similar triangles. Now we're going to get more into math and adding numbers in and applying the ideas, writing the proportions, and using the three AA similarity, SSS similarity, and SAS similarity to find missing values. So here, example 1, triangle ABC is similar to triangle DEF. Find the values of X and Y. So we're comparing, it says they're similar, so we're comparing corresponding sides. So the first side that I notice is the hypotenuse here and the hypotenuse here. So I'm going to write a proportion out of Y over 18 and this short leg here and this short leg here, 18 and 9. 18 and 9, right? And of course, when we're solving here, we can simplify. So first, I'm going to simplify 18 over 9. I can turn that into 2 over 1, right? So then I'm going to cross multiply. 18 times 2 equals 1 times y. So y equals 18 times 2 is 36, right? So this value right here is 36. And then next I want to find x. So I'm going to compare these two values to 18 over 9 or 2 over 1 as previously said. So 18 square root of 3 over x is equal to 2 over 1. And then cross multiply. 2x equals 18 times square root of 3. And then divide both sides by 2. And we get x equals 9 square root of 3. And if you notice, they've already done the work here, so they got y equals 36 and x equals 9 square root of 3. So this value is 9 square root of 3. Basically, everything in this triangle is double everything in this triangle. 36 is double 18, 18 is double 9, 18 square root of 3 is double 9 square root of 3. Okay, then we're going to look at example 2. I'll zoom in just a little bit too. It's a little bit more than I planned. Okay, so here example 2, a person 6 feet tall casts a 1.5 foot long shadow at the same time that a flagpole casts a 7 foot long shadow. How tall is the flagpole? So same thing, we're comparing corresponding sides, right? So we've got this side and this side, 1.5 and 7. So I'm going to write a little ratio. And that should be equal to this guy to this guy. So 6 over x. And now I can cross multiply. 6 times 7 equals 15 times x. 42 equals 15. Oh, sorry, not 15. 1.5x. Divide by 1.5. Divide by 1.5. And x is going to equal, you need your calculator, but x will equal 28. And I know that because it tells me right down here in the problem that it's 28. Okay, so it's all proportionate. Whatever the ratio of this to this is, this to this has to be the same thing. So you write a fraction, and it should be equal to this fraction. That's what we're doing with everything here. All right, number 1. We are looking for line segment JL, which is where the X is down here, okay? I know in these two triangles that they are similar because of the AA similarity rule. This is 90, this is 90, and this angle is marked congruent to this angle. And if two triangles have two congruent angles, that means they're similar, right? Because the third angle automatically has to be the same as well. So I'm going to compare these two sides. They're corresponding, so 10 and 20. 10 over 20. And that should be the same thing as 13 over x. And then for the sake of not having big numbers, I'm going to simplify 10 over 20 to be 1 over 2, right? Just divided the top and the bottom by 10. Okay, so now I have 1 times x equals 2 times 13, which is x equals 26. So here, line segment JL equals 26. That's our answer. Okay, number 2. Same type of thing, solve in the exact same way. I've got this triangle, and it's actually two triangles. It's this smaller guy, GHW, this little guy, inside of this big guy, GIU, right? So there's two different triangles here, and I am looking for side IU, this guy. So I am going to compare the smaller triangle to the bigger. So this side right here, 26, compared to the whole side of the big triangle, which is 26 plus 13, or 39. And that should be equal to the bases, the smaller base compared to the bigger base, 20 compared to x. So the small side compared to the whole side should be equal to the small side compared to the whole side, the big side here. Little triangle, big triangle, little triangle, big triangle. All right, and then I can also simplify this guy. I can divide the top and the bottom by 13. So I'm going to get 2 over 3. So I'm actually multiplying 2/3 times 20 over x. Multiply this guy, 3 times 20 equals 2 times x. 60 equals 2x, so x is going to equal 30. So the length of IU is 30 units. Okay, number 3. Here we go. This one's a little different because we can kind of use common sense here. The big triangle is isosceles. It tells us SV is 36 and QS is also 36. And so if the smaller triangle is similar to the bigger guy, that means this also has to be isosceles. So if this is 24, then this has to be 24. This guy right here has to be 24. So if this whole thing is 36 and this is 24, what must just QR be, this little portion down here? What plus 24 equals 36, right? 36 minus 24 equals 12, which is QR. That was kind of a common sense one. All right, and then BC. So here we've got this like bow tie looking thing, you know, we have vertical angles, right? We know what this shape is. So we got to figure out what are the corresponding parts. Well, I know that this base over here is corresponding to this guy. So I'm going to write that, 30 over 60. Okay, and then for this triangle, I've got 2 other sides. So I've got to be able to compare one side to another side, right? Well, this 23 doesn't have anything, there's nothing to compare it to here, but this x has something to compare to here. So this x goes to this 38.6. So we're going to say the smaller over the bigger equals the smaller over the bigger, right? And then before I cross multiply, I'm going to simplify. 30 over 60 is the same thing as 1/2. So multiply 2 times x, set it equal to 38.6 times 1, and then divide by 2. And that would be 38 is 19.3. So the length of this little guy, BC, is 19.3. Okay, and then 2 more, and then a word problem. Number 5 here, we have the big triangle and the little triangle, right? So I'm going to compare, I'm going to go little to big. So I'm going to say 16, this little guy, compared to the whole side here, which is 16 plus 8, which is 24. That's going to be equal to this little side here, x, compared to the whole thing, which is x plus 9. Now, yeah, that's true. We have x's in 2 different spots here, right? All that means is when we cross multiply, we're going to end up with x's on both sides of the equal sign. And we know how to solve those types of problems, right? So it's okay that we wrote it this way. All right, before I cross multiply, I'm going to simplify this over here. So I can divide the top and the bottom by 8. So this is going to be 2 over 3. And now I can cross multiply. So 3x equals 2 times x plus 9. 3x equals 2x plus 18 minus 2x on both sides, and x is going to equal 18. So the length of LM, this guy right here, is 18. All right, and then number 6, the big guy. We're looking for line segment QP, which again is this little portion down here. We're going to solve it like we did one of the top ones up there. So we're going to say, I'm going to write in green so it doesn't mesh with this red I wrote down too far. I'm going to say little compared to the whole thing. So 30 compared to 30 plus 10, which is 40. That's one ratio. And then I'm going to compare little, 32, to this whole side, which is 32 plus x. And I'm going to simplify this 30 over 40 to just 3 over 4. Divide the top and the bottom by 10. So I multiply this way, multiply this way. 4 times 32 equals 3 times 32 plus x. And then when I simplify that, I'm going to get 1280 equals 128 equals 96 plus 3x. 128 equals 96 plus 3x minus 96 on both sides. That gives me 32 equals 3x. And then when I divide, I should get about, I know I'm running into this down here, but about 10.6 repeating for this problem. And you can use a calculator too. I know I don't have a calculator here, but I did the calculations for this earlier. So it's about 10.6 repeating for this little section right here, which makes sense because if this is 30 and this is 10, this is a little bit bigger, 32, so this should be a little bit bigger than 10, 10.6 repeating. Makes sense. Okay, and then lastly, we have number 7. So it says, it's kind of like the flagpole one. The heights of 2 vertical posts are 2 meters and 0.45 meter. So here's a vertical post, here's a vertical post. This is 2, this is 0.45. The shadow, when the shorter post casts a shadow that's 0.85 meters, 0.85, what's the length of the longer post shadow to the nearest hundredth? So that's what we don't know. So we're just going to write a little proportion and then cross multiply to solve. So we're going to do 2 times 0.45. Oh, just not times, sorry. 2 over 0.45 equals x over 0.85. Okay, and then we're going to, cross multiply. 0.45x equals 2 times 0.85. And then when you multiply this and you divide by 0.45, you should end up with 4. Okay, this becomes 17. And 17 divided by 0.45 equals 4. So the shadow cast by the 2 meter tall pole is 4 meters. It's longer. It's probably like way late in the day. You know how like later in the day the sun's way over to the side, so it casts your shadow way out to the side. When the sun's straight overhead, your shadow's really tiny. Okay, same thing here. This is smaller than what the shadow is. So the sun's way over here. It's casting this long shadow. So this is 4. Okay, if you have any questions, let me know. Good luck on your assignment.